Okay, this is chapter 4.3. It's really part 2. We're continuing to look at modeling linear trends. So in chapter 3, we used either the mean or the median to describe a typical value in a distribution. Our choice depended on the shape of the distribution. So which measure of center did we use if the distribution was symmetric? So remember, if it was symmetric, we tended to use the mean, or the mean was a better option. That was because this was not resistant, or the mean is not resistant to outliers. If the distribution was skewed, we use the median. Right? So number 2, what's the shape of the following distribution of weights? Estimate the mean and median for the following distribution of weights. And this histogram is on page 164 of your textbook if you're interested. So notice that it is somewhat symmetrical. There's our idealized version of that graph, or sketch of that graph, rough sketch. So I look at the middle. Looks like the middle's right around here. So maybe around, let's see, around 155 pounds would be my best guess for the mean. And since it's symmetrical, the median is going to be very similar to that. Okay. All right, so number 3, turns out the mean weight of the above distribution is 152.5 pounds. In the absence of any other information about a person, this mean weight would be our best guess for a particular person's weight. But if we have additional information about that person, such as their height, then we may be able to more accurately predict that person's weight. So in general, what is the association between a person's height and weight? So you don't have a scatter plot for this to look at, but just taking your knowledge of the two variables, what we'd probably come to the conclusion is that taller people tend to weigh more. Or the taller you are, the more you weigh. And this is the key word there. I'm not guaranteeing it, we're just talking about the overall trend. And number 4, given the tendency for taller people to weigh more, we should predict a larger than average weight for a person that is taller than average. And we should predict a smaller than average weight for a shorter than average person. Okay, so number 5, if using a person's height helps make our predictions more accurate, then the next question should be how much better? How do we measure this? The answer is a measure called the coefficient of determination. So let's take a short detour before we look at how this measure is calculated. So number 6, let's start by taking a look at what is meant when someone says that the regression line is a line of averages. Remember that our best guess for an individual's weight, without knowing their height, is the mean weight of all people. So if I didn't know how tall someone was and I had to guess their weight, I would guess that they weighed 152.5 pounds. So what if I'm told that the person is 66 inches tall? Well, then our best guess for their weight is to find the average weight of all people 66 inches tall. So we'll use the scatter plot below to estimate the mean weight for people approximately 66 inches tall, or between 65.5 and 66.5 inches tall. So that's this slice right here. This starts at 65.5 and goes to 66.5. This is all those folks that are around 66 inches tall. So if we guess what that average weight is, we're going to take something in the middle, probably guess maybe 145 pounds or so. So the mean weight of the people in this slice is marked with a triangle in the scatter plot below. This is number 7, and is equal to 141.5 pounds. So it's quite a bit smaller than our original prediction of 152.5 pounds. So not only is it a bit smaller, but it's hopefully also more accurate. It gives us a better prediction of the height or the weight of someone who's about 66 inches tall. And this triangle here may not be quite as visible on your papers. So there's the triangle marking the average for those people around 66 inches tall. And number 8, if using the mean weight for people approximately 66 inches tall gives us a better prediction, then we should do this for all of the different heights. Following scatter plot marks the mean weight for 4 additional heights. Note that these means fall nearly on a straight line. We've got mean heights of looks like about 65 inches tall, about 66 inches tall, Got one in here for about 70, maybe 68 inches, about 72 inches. So you mark the average weight for each of those heights. Okay. The regression line, this is number 9, is included in this last scatter plot and includes the means for most of these heights. In theory, these means should lie exactly on the regression line, not just near the regression line when working with actual data. This may not be the case though. Okay, so again, the previous scatter plot looks like those means all fall almost on a straight line. And it turns out they're also very, very close to this regression line. So here's our regression line. And this is what we mean by a line of means or line of averages. All right, so number 10, back to the original statement that the regression line is a line of averages. When you use the regression equation to predict someone's weight, the regression equation gives you the mean weight for all people of that height in the population. The series of scatter plots can be found on page 165 of your text.